All right, 8th graders, we are going to actually skip problem 3.2, and today we're going to do problems 3.3 and 3.4. So in your packet, you need to just blow past 3.2. We may never do that. All right, so it says, on the grid below, connect K to L. So that's what we're going to do. And it says draw a right triangle with that as its hypotenuse. I'm going to color code this. And then it says find the lengths of the legs of the triangle using the Pythagorean theorem. So I'm actually going to draw the legs the opposite way because we're going to draw the squares off the legs. So we're going to go here and here. So the Pythagorean theorem says that the square off of each side length, the leg, adds to give you the tilted square's area. So this is a 1, 2, 3, 4, 5. So that means this is going to be a 5 by 5. And a 5 by 5, if you counted up all the squares inside, will give you an area of 5 times 5, which is 25. And over here, you have a leg of 2. And a 2 by 2 gives you a square with an area of 4. So we are no longer asked to draw this tilted square. This is really not very proportional, but that's okay. So basically you just add these two numbers, 25 plus 4, to get 29 for the tilted square that you do not need to draw. And then once you know this square's area, the hypotenuse, that's the side across from the right angle, the longest side of the triangle is the square root of the square's area. There you go. We're going to do the same thing connecting M to N. You're going to squeeze all yours on one sheet. I have another one, sorry. So here's M to N. And you're going to drop a triangle. And you're going to draw squares off of both of the legs. So a square means that all sides are equal, all corners are 90 degrees. So a 4 by 4 square will give you an area of 16. And a 3 by 3 square will give you an area of 9. So the tilted square that you don't have to draw will give you, it's going to be over here, an area of 16 plus 9, which is 25. That means the side length is the square root of 25, and this is a beautiful, perfect square, so 5 is what you should put. And we're going to do the same thing with OP to Q. So connect the dots. I know yours is getting kind of jumbly now. Drop the triangle. And it doesn't matter if you drop the triangle this way or above like I did in the very first one that I erased. It's still the same exact triangle. So on the side here you have a 3 by 3, 3 spaces by 3 spaces, giving you an area of 9. If you want, you can look and see that there are 9 squares here. That's how we get this area of 9. And then the 6th square, it's going to be even farther than I can draw, is 6 times 6 is 36. And so the tilted square that you don't need to draw is 36 plus 9, looking for the area, and that gives us 45. So since we know this square's area is 45, the side length is the square root of 45. And if you do want to keep thinking about what that approximately is, we know that 49 gives 7, and 36 gives 6. So this is definitely 6.7-ish. It's closer to 7 than 6. All right, the next question says to draw on dot paper, which there is no dot paper. It's okay. 2 points that have the square root of 13 distance. So what we're thinking of, and you have dot paper, and you're just going to follow the dots here, is you're thinking of what two squares add to give you 13. So I need to know a red square number and a blue square number that add to give 13. So if you know that this square is 13, you need to figure out two square numbers that add to give you 13. So let's think of our square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Are you seeing what I'm seeing? 9 and 4. So a square area of 9 and a square area of 4 give you a tilted square area of 13. Therefore, a triangle that is a 3 by 2 will give you a hypotenuse, a diagonal length of the square root of 13. So go ahead and fill out how you know the distance between the point is the square root of 13. And then just take a moment and see if you can draw the square root of 20. Just on the side. Go ahead and pause. So the two squares that give you 20 are 16 and 4. So a square that has an area of 16 and a square that has an area of 4 will give you a tilted square with an area of 20. So a 4, because that's the square root of 16, by 2, because that's the square root of 4, will give you a diagonal hypotenuse that is the square root of 20. So this doesn't look exactly like yours, but it's the exact same thing. And the question is, do these three numbers make a right triangle? So the question is, if it's a right triangle, the Pythagorean theorem works. Now, you haven't actually seen the Pythagorean theorem written like this yet, but basically, if you have a triangle, and this length is A, and this length is B, and this length is C, then A's square plus B's square will equal C's square. Oh my. And this is actually the formula, A squared plus B squared equals C squared, that's going to show if something is a right angle or not. The Pythagorean theorem only works for right triangles. So this question is 3 squared plus 4 squared equal to 5 squared. And you have a lot more space to write than me. So the question is 9 plus 16 equal to 25? And the answer is yes. So a 3 by 4 by 5 is a right triangle. So now let's check with 5, 12, and 13. So is 5 squared plus 12 squared equal to 13 squared? So the question is 25 plus 144 equal to 169. That's like a question mark there. So the answer is yes. So this is also a right triangle. Okay, 5 squared plus 6 squared, does that equal 10 squared? Now, just make sure you understand that C is the biggest side, because 90 degrees is the biggest angle. That's why C has to be the biggest side. A and B are interchangeable. It's the smaller two, but the C does have to be the biggest side. So is 25 plus 36 equal to 100? And that is a no. That does make a triangle, just not a right triangle, because 5 and 6 is more than 10. All of these actually make triangles. Okay, so 6 squared plus 8 squared, does it equal 10 squared? So that's 36 and 64. And that is a yes. 4, 4, and 4, that's an equilateral triangle. And triangles with all the same sides have all the same angles. So since you know the three angles of a triangle add to give you 180, an equilateral triangle is 60 by 60 by 60. So this is definitely a no. And you can also prove that with the Pythagorean theorem, showing that 4 squared plus 4 squared definitely does not equal 4 squared, because 64 plus, or 4 squared is 16. 16 plus 16 does not equal 16. And the last one, looking at that, that's an isosceles triangle. And isosceles can be 90 degrees, but this would have to be the biggest number, because the 90-degree angle is always the biggest angle. Because if you take 180, which is what all the triangles add up to, and you take away the 90-degree angle, you only have 90 left for the other two angles to add to give you. So this definitely is also a no, but you can show that, showing the Pythagorean theorem is not satisfied. Whoops, equals, does not anyways. So 1 plus 4 does not equal 4. So what statement can you make about triangles that a squared plus b squared equals c squared? Well, you can say that if that works, then the triangle is a right triangle. And then it says, what statement can you make if they do not satisfy that? Then it is not a right triangle. You know, you actually don't have these on your this one on your sheet at all. Okay, so let's just move down here. Don't worry about that if it's not on your sheet. All right, 12, 16, and 20. So is this a right triangle? So is 12 squared plus 16 squared equal to 20 squared? So 12 squared is 144. 20 squared is 400. Do you know what 16 squared is? If you don't, you can just grab your calculator and do 16 squared. This little squared button is right here, and it is 256. So if you want to like add these on the side, so that's 10, and that's 400. So this is very exciting. This is a right triangle. Next up, 8, 15, and 17. And again, this is like in question. I should be putting a question mark there. So does 64 plus 225 equal, I'm guessing you don't know what 17 squared is, so let's practice this calculator thing again. $289. So you could do 225 plus 64, and guess what? It is. These are actually called Pythagorean triples. They're the whole numbers that work to give you a right triangle. So the last one here is 9 squared plus 12 squared equal to 16 squared, and you could put 12 squared first. It just matters that these are on this side and this one's on this side because it's the biggest number. So 81 plus 144, does that equal 256? And the answer is going to be no, because we already are getting a 5. So this one is not one of the Pythagorean triples. All right, there's a lovely, exciting last problem, and it says, which of these triangles are right triangles? And this is where we're going to have our grand finale today. So one thing that you can try is taking the corner of a piece of paper, which I can't show you very well, and just seeing what angles even could be the right angle. So I'm taking my paper, and this looks like potentially it could be. The others are definitely not. This looks like potentially this could be with a piece of paper. This looks very right. This is definitely a no. We don't even have to try anything there. This looks very right, and this one is definitely a no, because if I'm putting paper into each corner and the sides are not lining up with the paper. Okay, so what we're going to do is the two flat ones, Q and R, we can easily draw these squares off the edge. So this is a 4, and this is a 9, because it's a 3 by 3. And so this side length would be square root of 13, because it's a 2 by 3 triangle. So you can say that 2 squared plus 3 squared equals the square root of 13 squared. Now, what is the square root of 13 squared? Square root of 13 times the square root of 13 is the square root of 169, which is 13. Because you can write that as the square root of 13 times 13. So anytime you're squaring a square root, it just gives you the number. So this is definitely a right triangle. And R is also a right triangle. This is 2, a side of 2, so the square is 4. This side is 1, 2, 3, 4, 5, 6, so the square is 36. So 36 plus 4 is 40, which means this diagonal length is the square root of 40. So again, 2 squared plus 6 squared will equal the square root of 40 squared. And 2 squared is 4, 6 squared is 36, and the square root of 40 squared is 40. So that's why that works. So this is definitely. Now, the other two are going to take a little bit more work, M and N. Let's look at N. So this side length is made from this triangle, which is a 1 by 2. So again, 2 squared plus 1 squared is 5. So this diagonal green length is the square root of 5. This diagonal length is made from a 4 by 2. So 4 squared plus 2 squared is 16 plus 4, which is 20. So this diagonal length is the square root of 20. And then the one at the bottom is just a lovely flat 5. So the question is, so 5 is the biggest side. This is the potential 90-degree angle. So this is going to be our C value. So is the square root of 20 squared plus the square root of 5 squared equal to 5 squared? Well, the square root of 20 squared is 20. The square root of 5 squared is 5, and then 5 squared is 25. This does work, so this is a right triangle. Okay, now we're looking at M. It's our last one. So this is a 2 by 1. Every 2 by 1 is the same. We just recalled that it's square root of 5. This also is a 2 by 1, so that is square root of 5. And the bottom, the biggest side, the side across from the potential 90-degree angle, is a 3 by 1. So 3 squared plus 1 squared is 9 plus 1, which is 10. That means the square off of the diagonal has an area of 10, which means the side length is the square root of 10. So the question is the square root of 5 squared plus the other leg, the square root of 5 squared, equal to the square root of 10 squared? Well, the square root of 5 squared, again, if you want to do this, it's the square root of 5 times the square root of 5. That's a square root of 25, which is 5. So is 5 plus 5 equal to the square root of 10 squared is the square root of 10 times the square root of 10. That's the square root of 100, which is 10. So that is another yes. So the square root squared is the number. In this picture, there are 4 right triangles. It can be slightly deceiving. You definitely needed to do the work for M and N because you could not be clear just looking at it. Q and R you could be. P and S you can be, but Q and N definitely are in question. And if you want to try P, just to make sure, like if like S, there's just no way. Let's say you think P might be. Well, we already know that a 2 by 1 is the square root of 5. And we already see that this is 1, 2, 3, 4. And then this is a 2 by 3. So 2 squared plus 3 squared is 4 plus 9. That's the square root of 13. Okay, so now you need to figure out which length is the biggest. So this is the longest side because square root of 13 is less than 16. 4 squared is 16. So then you're checking, is the square root of 5 squared plus the square root of 13 squared equal to 4 squared? And it's not, because 5 plus 13 is not equal to 16. So when in doubt, definitely check it. But hopefully that makes some beautiful sense, and I hope you have a wonderful evening. Think about something positive that you are blessed with tonight.